అక్కడ పట్టించుకోడు లేదా లేఅవుట్ ప్యాచ్ చేసేటువంటి జాగ్రత్తగా డబ్బు లేకుండా
Hey, hi everyone. Good morning.
Good morning, sir.
Sorry, because of this elections, the institute was closed, so that's the reason couldn't take the class. All right. So, any questions, guys? Okay. So in last class, we started discussing about this recommender system. So I'll give a quick recap and then we'll get into a use case. So, recommender system we discussed like how, why is it important, where all it can be used. So it is a more it's a kind of a generic solution. Though we have seen recommender system on some e-commerce website, but nowadays this is being used in a lot of different other ways. In the business. It could be for internal teams, also for on any kind of applications. Uh, this recommender system is getting used where based on this recommendation system, it will recommend some important documents or important articles or items, technical or it could be functional to the users. And now this recommend in any kind of a digital product where we have a lot of different items included, there we are seeing that recommendation system is being used. So the way it works will remain the same, but it's like little bit of customization is required so that it can be fit to different kind of scenarios. So we did discuss about two types of recommender system. One is like content based, another is collaborative filtering. So what is the what is content based? In the content based, it's all about. So here in the recommender system, we have two different entities. One is the users, and the second is the items. So these are the two main important components in the recommender system. So in the content based, it's more of item specific. It the whole algorithms consider the similarities between the items, and these items, as I said, it could be anything. It could be product, it could be blog, it could be article, it could be documents. Whatever you would like to recommend to your users, that will become the item. So here we take the attributes of the item. So we call it as content. So whatever is the content of that particular item, we take those things as a features, and then based on those features, we find out the similarity between the items. So it's all about like depending on the content of that particular item, we see which of the items are similar. Okay, and based on the similarity, we recommend the items to the user. So this is a content-based recommender system. So here in this slide, if you see that if these three items are most similar, and if this user has liked the item one and item two, then based on the similarity, this item three will be recommended to that particular user. So this is a simple approach which this particular algorithm uses for this content-based recommender system. So then we discussed about this particular example of movie recommendation system, where this user has given ratings. She has watched the movies and she has given the ratings, And here we will consider the ratings as well as the attributes of this movie, and then based on that we will recommend the appropriate movies to this particular user. So as I mentioned, you need to understand, it's not about whether the person and the user has purchased a product or viewed a product or accessed that particular product. This is all about whether the user has liked that particular item or not. So to understand whether they have liked it or not, here we are going with ratings. So for different scenarios, we may have to consider different way of understanding whether the person has liked it or not. So for example, in one of the solutions, what we did is we haven't given that feature of liking or providing the rating because it is more of an internal system. So what we did is to understand whether that person has liked it or not, we capture the time that particular user has spent on that particular page of that article. It was more of an article page. So if the user does not find it relevant, definitely within few minutes he will close the window or he will come out of that page, right? If he likes it, there's a high chance that he will spend more time on that particular page and he will go through the entire article. So there, instead of rating, we have taken the time spent on that particular page as as the feature which will help us in terms of understanding whether that person has liked that particular article or the blog. Okay, so here then we looked into the mathematics of this algorithm, where we have taken the user ratings and we have taken the attributes of the movies. So here we have considered the genres, and based on these two matrix, we came up with a user profile. Okay, so I hope you understood this whole thing, and if you have any questions, then please let me know. Then I can go through it again. So here we have multiplied the user ratings with the attributes of the movie to calculate this weighted genre matrix. And once this weighted genre matrix is calculated, based on that, we have come up with this user profile. Okay, and once the user profile has come, so whatever the unwatched movies are there, those would become the candidate movies for recommendation. And what we did is we calculated the weighted movies matrix to come up with a recommendation matrix, for that particular user. So here, based on the user profile, we calculate this movies matrix. Okay. We calculate this weighted movies matrix. We multiply the user profile with this movies matrix, which is nothing but which explains the attributes of these all movies. And then based on that, we calculate this recommendation matrix. Recommendation matrix is nothing but the sum of all these weights of each movies around all the genres will give me the weightage for each of these items. And wherever the weight is high, that would be recommended first. And even you have seen that it's not about randomly recommending the products or the items to the user. You have to rank it in a order in such a way that the item which has high propensity to be liked, that should be shown first, or that should be recommended first. There is another so now you may ask, like, what if this particular user is a new user? Let's suppose we do not have any history of this particular user. It's a first time. So we call it as a cold start problem. Can anybody tell me what to propose to a user who is logging for the first time? Who is a first time user? How can we address those people? Even if you go and let's suppose you have subscribed to Netflix today, still it will recommend you certain movies. So can anybody tell me how it works? Any guesses?
Mostly viewed by other users.
Right. So basically, not even, yeah, there wouldn't be any user similarity or as such. They will recommend the most popular ones. So it could be based on the IMDb rating, like, overall, in that particular region, which of the movies have been rated high, okay, uh, by other users. That, or second could be, it's all about some other institution like IMDb, and they are rating a very high to those movies. Those will be recommended. Otherwise, it would be based on the user ratings. So who all have viewed in that particular region, for which movie most of the users have rated high. So those will be recommended to the new users. So that is known as popularity based recommender system. So in the interview, question may come like, how you will address the cold start problem. Then you can say that by using the popularity based recommender system. Okay, so even if it is a new application where you do not have any historical data, you do not have any user history, nothing, then you should go with the popularity based. If it is generic content, external content. If it is like more of an internal content, for example, I developed one application for internal employees, and this is the first time I'm launching. So here, I do not have any data with me. I cannot rank it based on popularity because I do not have any historical data. It's a first time implementation of that recommender system. So in that case, I do not have any choice rather than manually providing or ranking those items. Okay, so I need to first somehow with some means, whatever items I'm uploading, I have to rank it manually, saying that okay, these are items. There's a high chance that the people may like it. So that's something I might have to do it manually and then host it or then populate that particular application with those items. Okay, so once we got this weights. Weighted average for all these movies. Then based on those weights, this particular algorithm will recommend the items which is having the high weightage. So this is what is the content based. Now let's get into a use case. So we will build a movie recommender system only. So let me show you the data first. Yeah, so okay, now how you have to prepare the data. Okay, so for the recommendation system, first is the data could be very large. Just imagine a Netflix kind of a scenario or Amazon kind of a scenario. Just imagine how many users would be there, right, worldwide. How many items would be there? Okay, so now these algorithms which we are going to discuss, these are like scalable algorithms. This can work on larger data set. Generally, for the recommender system, we have to deal with larger data set. Now, again, this data could not be in one single table. It could be multiple tables. So, for example, here I have movies as a separate uh, table, ratings as a separate table, tax as a separate table. So I have a separate tables for each of different information. Just a second, guys. Okay. So yeah, so we will have a different tables in the database, and here we will see that how we can join all these tables, how we need to prepare the data to train this recommender systems. So here we have movies. Let me open that. Okay. So movies data looks like this. We have a movie ID. So definitely if there is a database, then you will find some unique IDs for each of the movies. Here there is a movie name and the year in which that movie got released, along with the genres. And if you're seeing that there are multiple genres in the same cell, right? So this particular Toy Story, it belongs to all these genres, right? And look at the data size. Again, comparing with the real data set, it is not that big. But if you see, there are 34,209 records. So pretty comparatively, it's a big data. Then we have ratings. So it's so I'll show you. You're seeing the right that this data set is too large for the Excel grid. If you save this workbook, you will lose the data that wasn't loaded. So so look at the count. Okay, I think I'm not sharing the new screen. Yeah, so this is the rating sheet. So there would be multiple users who might have watched one single movie. So when it compared to movies table, all the rows would be unique, right? Every row will have a unique movie ID. So still that would be limited, right? So if I have to upload 100 articles, then it will be limited to 100 articles, that particular table. But here, the users coming and viewing those items could grow to any size. Okay, one person can view a single item multiple times, or there could be multiple users viewing one single item, right? So here you're seeing it's almost like how much? 10 lakhs records. Okay, so user ID, if you see this 111, so this is a user ID. This particular user has watched these three movies and he has given this particular rating at this particular time, right? So typically we will use these two data sets, but in the real scenario, you may have to deal with multiple other data sets also, to bring all the attributes of the items, or, to collate the user behavior and all those things. So this is our data. So let's go and quickly build this recommender system on Python. Okay, so I am sharing my Jupyter notebook now. All right, so all this data in my folder is in zip file. So and sometimes you may get the data in a zip file. So that zip file you can directly upload into your Python environment, and you can unzip it, and then you can access the relevant files in that particular zip file. So these are all standard libraries which I've imported, and then followed with this particular package, zip file package. If you use the zip file package, it will read and extract the files from the zip. Okay, so after doing that, here I'm reading this movies.csv and the ratings.csv. Here in Python also, there are certain packages which can process even larger data sets. So there is a package known as Dask. Okay, so that's something you can use, and that what it does is it is capable of processing the data parallelly. Okay, in your single system. So if you have a 4-core machine, So it will run parallelly on each of the cores, and then it will process the data. So there is another package known as Ray, RAY. So these are like for faster computation and for processing larger data set, you can use those packages. And there are multiple other packages. So if you go on Google and search that, some Python packages, for big data processing, it will recommend you, or it will give you certain list of Python packages which you can use for processing larger data. Now we are using even the pandas is capable to some extent, but when it goes to a large data, then Python may fail. Okay. Uh, yeah. And then the final, as Saurabh mentioned, the final option is Spark. So for the Spark, the only thing is like that will also do that parallel processing. But if you are using Spark, the more effective it would be if you are running Spark on a cluster. Okay, so I will explain you. I think I've explained you in the beginning. Like cluster means you will have multiple systems or multiple nodes connected to each other. Like instead of one single server, you will have multiple servers connected to each other, and the data will be distributed among multiple servers. If you are working in your local machine, which has multiple cores, then internally the data will be segregated or distributed among those cores. So yeah, so there are various options. So in the interview, if the people ask like, how you will address, then you can say that if it's a single machine on which I have to run, so I may use these packages. If I have to, and even I can use Spark. And then if I have to scale it to multiple servers, then I'll go with a cluster, and then I can use Spark on that. So there are multiple uh, platforms on top of Spark, like Databricks is there, one of the Cloudera is there, right? So you can use those kind of platforms, to handle big data. Okay, so here it's important in recommender system because it has to do a real-time processing. People cannot wait for long time, to get the recommendations. It has to be processed on a real time, and you will see that such a large data it needs to process, and it has to give the recommendation system within fraction of seconds. So here the platform would play a very important role. Building an algorithm is one task, but the bigger task is deployment and scaling that particular solution to such an extent that users can get recommendations within fraction of seconds. All right, so going back to this use case, so here is the data, and you are aware of this all code. So we are reading that particular data, and here I'm doing some kind of a pre-processing. It's not something I can directly use this data the way it is. I may have to do some kind of pre-processing in this data. After every movie, there is a year associated to it. So what I can do is I can extract that year and save it in a separate column. Okay. And then you have seen there is genres in a single cell. So that's something I have to pre-process. Either you can run some pipelines, build those transformation pipelines on your database side only, and you can create a separate views where you can process the data, and the way you want the data to be fed to this particular algorithm, you can process it and save it in a separate table or create a separate view for it, okay, in your database. Or else you have to create, you can also create some processing jobs on Python. So here, this is the example. Every time the new data is getting loaded, you have to push it through these pipelines, which will clean the data, process the data, and then send it to the algorithm. Okay, so here what we did is here we have taken this title column from this particular data frame, and there we are doing this string extract. So str.extract, this is a function, and from here, and in the strings uh, for in the text analytics, there is one what do you say, method known as regular expressions. Okay, so you can search more on this. So regular expression is a scientific, or I would say, uh, some logical expressions. For example, if you say star, you put star, then means it will extract everything, okay, from that particular text. And after the star, if you put some patterns, then it will go and search for those patterns and extract the text wherever that particular pattern is applicable. So here, from the entire text, I'm putting it as like this is the regular expressions which will extract the uh, the text which is inside the brackets. Okay, so it will look out for the bracket, and then inside the bracket there are four D's, right? So it will extract the four digits which is there inside the bracket. So it is something, for different purposes there are different patterns or different expressions are there in the text, okay, which you can use as is, and you can include that in your code to extract some kind of a patterns. If there is a custom patterns, then you may have to build some custom expressions by adding multiple expressions into one, and then uh, customizes based on your requirement. So here, what we are saying is extract a pattern where there are four digits inside the brackets. So that's something I'm extracting it and saving it in a separate column known as year. So if you see, it is here. So what it will do is it will extract that entire component along with the brackets and the year into this particular column. Then what I'm doing, I'm removing the parenthesis. So here, I will just extract uh, the dates, the number. Okay, and that I will do it. And then what I'm doing is in the existing title column, I'm going and removing that year part. I have extracted that particular year information in a separate column. So then again, I don't need it here in this title. So I'm removing the years from the title column. Okay, and after that, there would be some white spaces would be left out. Okay, so that white spaces or extra spaces, I'm going and removing it by this particular line of code. If you use this dot script, it will remove that white spaces. So what you can do is you can try this particular code. Okay, you can take any text and put some kind of a pattern, and you can use regular expressions and see that how it is working. For now, what you can do is you load this data. What I would suggest is instead of taking all the rows, take just 10 rows or 12 rows, and then you can execute this particular code line by line and see that how is it working. Okay, execute this line and then print the data frame and see that how it has extracted. Then run this particular line again, print the data frame and see that what is happening in this particular line of code. So like that, you can understand what's happening in each line. So what I did is earlier that my data was like this, where there was an year associated to this particular title. And now the data has been transformed in this form where year has been captured in a separate column and got removed from this title column. Now let's look at this genre. So here the genres has been segregated by this delimiter, like this is known as pipe, okay, vertical line. So I'm just removing that. So again, if you say split, what it will do is it will split that entire text with that particular delimiter. So here you can specify the delimiter. So it will create a list of all the words which are there inside that particular cell. Okay. So here, if you see, all the pipes have been replaced and it has created the list. Okay. Now that's how, genre, something I have processed. Now it would be easy if you have a list. Now on this list, you can iterate. So now what, if you have seen in the slide, the genres has been represented by each column, right? Now here all the genres have been captured in one single column. So here I am running this particular loop, okay, where what I am doing is I am extracting the genres from this particular column and creating a separate column for each of the genres. So this Toy Story, which belongs to these five genres, it will be marked one for these genres, and for rest of the genres, it will be marked as zero. So it is like kind of a one-hot encoding what we have done, right, for all the genres. So here, wherever there is a genre associated to that particular movie, it is marked as one, and wherever it is not there, wherever it is blank, I filled those blank values with zero. So this is how I have created this data set. Now let's go to the rating. So this is my rating data frame where I have user ID, I have a movie ID, I have a rating, and I have a timestamp. So timestamp, I don't need it. But as I mentioned, in some of the scenarios where you are capturing the timestamp when they have started viewing that particular item and when they have closed. So based on that difference in the timestamp, you can understand how much time they have spent on a particular item. Even the movies also, the Netflix guys, if they also capture whether you are watching that movie at one stretch. So if you're, because every time whenever we watch the movies on Netflix or Prime, we don't generally give the ratings, right? Even if we like that movie, so our tendency is if we watch that movie, we close that particular channel, and then uh, we forget or we don't give the ratings. So what to do in that particular scenario? If we like the movie, definitely we may watch it at one stretch. So there are certain series, right, where episode after episode we keep watching, right? If we like it. If it is not good, then we watch for some duration and then we come later after 10 days or then again watch some little bit. So there is some internal mathematical logic they will build, which will, based on which they will kind of come up with some kind of a rating kind of a thing, or they will score that particular movie for that particular user, whether that person has might have liked it or not. It's again a guess. So the guess is like if you watch it at one stretch, then that means you are liking it and you are not moving away from that from your television, and you are moving away once you have completed that particular movie. Okay, so those kind of logic also you can build if the ratings are not available straightforward. Okay, so I'm dropping the timestamp. I'm just using the user ID, movie ID, and the rating. Now I'm going to this recommender system. So here there is not much processing required. Okay. So in the content, this is just, I'm giving you an example. Let's suppose this is the user for which I have to provide the recommendations. Now this particular user has watched these five movies. Okay, and these are the ratings of those movies. So again, you have to make sure that how you are reading the user inputs. Okay, so here I've created a kind of a dictionary which I'm feeding it to this particular algorithm as a user input. And this dictionary has a title as well as a rating. So this is my dictionary, which I've read it as a data frame, and this is how the small data frame is used, as a user input. So this person has watched five movies, and these are the ratings, and based on this input, I have to recommend the movies to this particular user. What I have done here is okay, so we are filtering the movies by title. So whatever the movies he has watched, I'm filtering it from the main data frame where all the movies information is there to capture all the genres. and then I'm merging the input ID and this input movies, okay, to find out the genres and all those data. Yes. So this is how data look like. So these are the 5 movies which he has watched, and these are all the genres, which I've extracted from my main data. Because in this user input, I just had the movie name and the rating. Okay. From that, what I did is I just used those movie names and then joined and merged with the main data and then filtered only those particular movies so that I can get the genre information for those movies. Now, what we are doing here is, so this is my movies matrix. If you remember in the slide, this is my movies matrix, which has all the genres and, all the genres and the genres which are associated that with that particular movie has been marked as 1, otherwise it has 0. So it is the genre table which I have created, and this is my ratings matrix, okay, for those 5 movies. So now I have to multiply this rating with this particular genre table to create the user profile. Okay, so these were all the genres associated with these 5 movies, and this is my user profile. Okay, so this is all the genres. Okay, in that particular, from all the genres, these were the genres which were associated with those 5 movies which that this particular user has watched, and this is how I have come up with a user profile. So these are the kind of genres which were not associated with any of those 5 movies. So that's the reason it is 0. Now, whatever movies are there which are unwatched by this particular user, now I have to go and find out the weightage, for all those movies. Yeah, this is for all the movies. So this is just showing you the 5 top rows. So here we have taken genres of every movie in our original data frame, and we are dropping the unnecessary information. So we just want movie ID, even we don't require the names. With the movie ID later, I can call the names. So these are all the movie ID. These are all the genres, okay, associated to these movies. Here, I'm multiplying this genre table with the user profile and then creating and then finding out the weight. Okay, so I'm summing it up and then dividing it by the overall sum of the user profiles. So now this is how I got the weighted recommendation matrix. Now after that, what I did is I sorted the values. So sorted in a descending order. Ascending equal to false means it will sort into a descending orders. And these are the movies where the weights are higher. Okay. So now here comes like how many items you would like to recommend. Again, this is also something which can be evaluated. So shall we go and recommend 5 or 10 or 15 or 20? How many should we recommend? So if you look at any of the applications, so it has in the first page it will show certain number of recommendations. If you want more, then you can keep scrolling or you can go to the next page, to see the number of recommendation. And the question comes like, how many recommendations should be shown on the first page? Yeah. So firstly, it depends on the space available. It should not look cluttered. Like you cannot show 20 recommendations on the one single page. Okay. In terms of UI, UX, it will not look good. The same time, you cannot show just 1 or 2. Again, that will also not look good. What would be the appropriate number of recommendation you have to show per page? That depends on the space, that depends on UI UX, and that also depends on on the testing which you will perform. So how you can perform testing is For example, let's suppose there is a user ID 1. He has watched, let's suppose, 10 movies. Okay. But you pass only 5 movies information to this particular algorithm and generate the recommendation. So whatever recommendations are coming, then you match those recommendations with the rest 5, which you haven't considered as an input, and see that those recommendations are matching to those movies which has he already watched, which you haven't considered. So in that way, you can check how good your recommendation system is working. Okay, how good your model is. If it is matching, if like out of 10 recommendations, 5 recommendations are matching, then you can go ahead with 5 recommendations, or you can see that if it is like out of 10, if all the 10 are matching, then you can extend it to 10. But again, you have to make sure that how many recommendations would look good on your particular platform. Right? It should not be too cluttered, or else you can just display few and then put a scroll or put something like moving to the next page kind of a feature, so that people can go and look out for other recommendations. Okay, so now these are my top 5 recommendations based on the score. Okay, and here I'm printing the top 20 recommendations. So here I'm based on these movie ID, I'm bringing uh, all the information related to those particular movie IDs. So here, if I show, yeah, so from all the from the entire recommendation table, I'm just reading the top 20. Okay, so I think it's not sorted. Top 20. Okay, so you can, I'm not sure either. Here it is showing different, it's showing movie ID 5018. Here it's showing 673. Yeah, 5018 here, right? Yeah, 5018 movie ID. This is Motorama, and this is the genre, and this is the year. In fact, I've seen, for example, now it's about the human logic or common sense which you can apply. For example, if the user profile, if he's a young person, okay, with of age 20 or 25, if you are recommending a very classic old movie, though it may match with all the genres he has liked, but probably he may not like those classic movies, right? He may like the latest and the recent movies. So later you can even filter these movies based on the year. Okay, so you can show those movies which are more recent, more new, and then you show the classic ones. And that's how you might have seen in the Netflix or Prime. It will first recommend all the latest movies, and then if you keep scrolling, it will then show all the classic movies, okay, in that particular genre. That also something, okay, you can apply. Now, finally, I've given you the advantage and disadvantage of this content-based filtering. The advantages is it learns the user preferences. Okay, so what the user is liking or not liking, it is highly personalized to the user. Here, I am not considering what other users are liking. Here, I'm just concentrating on that particular user, whatever he has liked it, based on his liking, based on his preferences, I am recommending the items. Okay, so it is more personalized. The disadvantage is it doesn't take into account what others think about that particular item. Okay, so whether the other people are liking it or not liking it, I'm not capturing the trend. I'm not capturing what is how the other users are perceiving that particular item, right? Extracting data is not always intuitive. So You may have to do some kind of pre-processing to clean it and to make it more intuitive. Determining what characteristics of the item the user dislike or like is not always obvious. As I mentioned, here we are going with the genres, but sometimes it would be difficult. For example, I'm going with a blog. Okay, so in the blog, capturing the attributes, what attributes should I capture of a particular articles or particular documents? That would not be straightforward, and you have to think about it. You have to understand how the user may search for the documents, what kind of things he may like or he may not like in that particular document, and then you have to come up with that feature list. Okay, so this could be one of the challenging aspect when it comes to content based. Okay, if it is clearly defined characteristics and attributes of those items, then there is a no problem. But if it is not, then you may have to spend some time in terms of capturing those attributes. So any questions on this content based? And it may generally take a little bit of time to compute. So if you're not getting the results, so that means it's running. Okay, and you should give some time for this particular algorithm to run and to give the output. All right. All right. So if there is no question, then let's jump to collaborative filtering. So as a name, we can understand that collaborative filtering means it is collaborating. Okay, it's collaborating with multiple uh, components. Okay, so here we have two different types of algorithms under collaborative filtering. One is the user-based collaborative filtering, and the second is the item-based collaborative filtering. But in these both um, techniques, we will capture the user's behavior. In the entire data, how the users are behaving. Okay, and behaving in the sense what they are buying, what they are not buying, what they are liking, what they are not liking. In the first case, we will understand how what all are the users are having a similar kind of a preferences. So let's suppose if the 10 people they liked a certain set of movies and they disliked certain set of movies, and that's very common on in all those for all those 10 users, then those 10 users are considered as a similar users. When it comes to item, again, in item based, we will look out for those items which has been liked and by common set of users, and which are not liked by common set of users. So in that case, we will understand which of the items are similar based on the liking and or based on the rating given by the users. Okay, so a user-based collaborative filtering is based on the user's similarity, and item-based collaborative filtering is based on the item similarity. So let's see this. Now there was a user, who liked these three movies, and there is a new user, and this new user is very much similar to this particular user. Why? Because there is two movies, whatever she has watched, those are like common movies, which even this particular user has also watched. So these are the two common movies. In that way, these the preferences of these two users could be very much similar, right? So, but this particular user has watched one more movie, okay, which also he liked. So now there is a strong chance that this particular user who has not watched this movie may like this movie. In that way, this particular model will recommend this particular movie to this new user. Here we are not seeing that, okay, whether these movies are having the same genre or not, or we are not bothering about the content of these particular items. Here, it could be like these two could be action, or this could be completely or altogether different genre like drama, right? But if this person has liked these two movies and also like this movie, so there is a strong chance that this particular user, which has like common uh, pattern as this compared to this guy, then there is a strong chance that this particular movie will be liked by this user. And generally, in our real life also, we does the same. We do the same, right? So if we are close friends and out of five friends, four friends have watched one movie and they all liked it, then there's a high chance that this fifth guy will also go and watch that and he will also like it, right? So the same concept we are using in this collaborative filter. So the how it works. Now these are all the active users, and they have given the ratings to all these particular movies, right? Now based on these ratings provided by this user to each of the movies, I will go and find out the similar users. Okay, now let's suppose I assume that this model has to recommend certain movies to this particular user. Okay, and let's suppose these are all uh, user list of users, and I want to understand whether this particular user will like this particular movie or this particular movie. Okay, that's a question mark. So basically, I would like to predict the ratings, okay, for these users, whether this particular lady will like these movies or not. Okay, so second. So it's all about similarity. So you know how the similarity would work. Um, you take the values, and these will consider this you consider as a coordinates, okay, for each of the users, and based on these values you can find out the similarity score. So you know how to calculate the similarity score. You can go with a Euclidean distance, calculate the distance, and based on the distance you can um, calculate the similarity. Now let's suppose this particular user, when she has been selected as an input user, so this particular lady will be mapped, or will be uh, we will find out the similar user with this particular new user. So for this user with this user, the similarity score is 0.7, with this particular user it's 0.9, and with this particular user it's 0.4. Okay, so these are the similarity weights. Now yep, so just observe this, guys, these spaces. Okay, so I'm taking these three users, and it is a very small example. So in the real scenario, it could be thousands of users. I'm taking these three users, and the movies which this new user hasn't watched. Okay, I'm considering the ratings for those movies. Okay, so she hasn't watched these movies, right? I'm taking the ratings of these two movies for these users. Okay, now I'm finding out, and then I'm multiplying with the similarity index. Similarity is how close these users are with that particular new user, right? So this is my similarity score, 0.4, 0.9, 0.7, right? Based on the past pattern. So this is my similarity index. So this particular user is 0.4. So lower the value, lesser the similarity, higher the value, higher the similarity. The most similar user out of these three is this particular user, where the score is 0.9, and then followed with this particular user, 0.7. So whatever rating he has given to this two unwatched movies by each of these user will get multiplied with the similarity index, and then this weighted rating matrix will be calculated. So 9 into 0.4, 3.6 for this particular movie. So this user hasn't watched this particular movie, so it is blank. So 2 into 0.9, 1.8, 8 into 0.9, 7.2. So like that, weighted rated rating matrix will be calculated. Now, we have the similarity score, a similarity matrix. Now we have this weighted rating matrix, which we have just calculated. Based on these two matrices, this particular matrix will be calculated. How it will be done is, so let me understand. Mm, okay. Okay. So now this particular movie has been watched by these two people, right? Okay. So 7.2 and 4.9. So if you sum it up, it will become 12.1, right? So these two users for this particular movie, right? So this is 12.1. You just add this ratings by these two users. So this is 12.1. For this particular movie, all these three people have watched. Okay. So 3.6 plus 1.8 plus 3.5, it is coming out to be 8.9. So it is the sum of this weighted rating matrix for each of the movies. Now they have also considered the similarity. The similarity of these two users with my new user. What is the overall sum? So it is 0.9 and zero point 0.7. So it is 0.9 plus 0.7. So it is the weighted sum of the similarity. Here it is the sum of all the three. Now what they have done is they have divided this sum, this similarity sum with this particular this by this. So 0.9 plus 0.7 would be 1.6, right? So if you multiply this, divide this 12.1 by 1.6, it will give you 7.5, right? So this would be the score for this movie for this particular new user. She is the new user for which a user for which we have to give the recommendation system. For this particular movie, this is the score. Now, ultimately, what we are getting for all the movies, we are getting the score. Okay, and then we can sort the score and see that where the score is highest. So those particular items will be recommended to this particular user. So here, if you see, we are using the similarity matrix, okay, which is giving me which of the users are similar to this particular user. We are considering that, and we are also considering the rating provided by these particular user on the movies or on the items which has not been watched by this particular user. And based on that, we are calculating this recommendation matrix. So this is the way this user-based collaborative filtering works. Now in the item-based collaborative filtering, what will happen is this will get swapped. Okay. So there we have to find out which of the items are more similar, and based on that, we have to give the recommendation. So here in the item-based collaborative filtering, what will happen is here instead of users, there would be a list of items, and here there would be users. So based on the item similarity, there would be a recommendation provided based on the item. If, for example, if I have bought, let's suppose a mobile phone, okay, so which all uh, which of the items are similar and people have liked and purchased along with the mobile phone, it will look out for those items. And based on the similarity of the item, it will recommend you the another item. So in this mobile phone example, it may not work because let's suppose Samsung phone is very much similar to give me some example, or Redmi, right? Redmi phone. So if I'm buying a mobile phone and if I'm going and using the item-based collaborative filtering, it may recommend me the Redmi phone, but it would not work better in this case. It may work, for example, in the blogs or in some other document recommendation system. Okay, and even it may work well for the movies recommendation system, but it would not work for a product-based kind of scenario. So there we should go with a user-based collaborative filtering, because a person who is buying a Samsung phone, there is a less chance that he will also buy the Redmi phone and he will like that Redmi phone, right? So in that case, those kind of recommendation will not be provided. So possibly a one single user, if he is buying a Samsung phone, he may also buy some headphones or some different products. Okay, that could be recommended to the users whoever is buying a Samsung phone. So we have to see that where exactly we can use a item based and where exactly we should use a, a user based. So in the user based, we are going with a similar users. In the item based, we are going with a similar items. Okay. And you may get confused with this item based collaborative filtering with the content based collaborative filtering. The difference in the content based in the item based is there we were finding out the similarity between the items based on the attributes of the items. There we are taking the feature set which represent the attributes of these items. But here in this item based collaborative filtering, we are not focusing on the attributes, but we are seeing who all users are buying this particular item. If more number of users have liked this particular item and this item, then these two items would be similar to each other. So based on the ratings, based on the common users who have bought these particular items, the similarity between the items will be calculated. Okay, you understood the difference? So here no attributes. Here based on the users and based on the ratings, we will find out the similar items. If let's suppose this is my Samsung phone, this is the headphone, and more number of people have bought Samsung phone and headphones, and they both like, and all those users like both these items, then these items will be similar. So in this way, what will happen is where in the content based, the items which are very much, in feature wise, which are very much similar in kind, we are recommending through content based. Here, the items could be dissimilar. Okay, for example, the Samsung phone and the headphones, these are two different products, but these two products can also be considered as similar. Okay, because the users have bought together and they have given the high rating. So if you use the item based collaborative filtering, there is a high chance that you can do cross selling and upselling, because here you can recommend a different, altogether different product. You might have observed in Amazon, when somebody is buying a one particular product, underneath, there will be a recommendation that people has also bought this along with this, right? And there would be a combo which they will show you, this plus this plus this. Okay, people have bought it together. That is coming through this item based collaborative filter. Okay, so where different kinds of products can be shown as a similar products and can be recommended together. Okay, so what is the challenge? So here I am just shown you the user based collaborative filtering method. Though in item based, what will happen is this matrix will get swapped, okay, transposed, where the rows would be items and the columns would be the users. That would be the only difference. Rest every calculation will be the same. Okay, so the challenges of collaborative filtering is data sparsity. Users in general rate only a limited number of items, right? So this is a major problem. What is sparsity? Sparsity means if you have a huge matrix, okay, if you have a huge matrix where you have, let's suppose these are all items. So just imagine Amazon kind of a business, millions of items would be there. So you will find millions of columns, and then the rows would be the users. So you will have millions of users also, right? So you will have that many number of rows. But now these users will rate only few items, right? In practically, and they may not buy. You will not find a scenario where they would have bought all the items, right? Out of the million items, they would have bought only few items, like 100 items maximum, right? So only you will find the ratings to those 100 items. For rest of the values will be blank. So if in a particular matrix, if more number of cells are blank, then that particular data is called as sparse data, okay, or we call as data sparsity, where you will find the values only in few cells. Most of the cells would be blank. So that is known as data sparsity. Cold start, difficulty in recommendation to a new user or the new items, right? So if it is a new user, how you will find out the similarity? Because you will not have any past history of that particular user, right? So here in this case, for this particular user, we could able to find out the recommendation, because for this active user, you have some past data available, historical data available. But if you do not have, then that is a cold start problem. And we have discussed, right, how to address that cold start problem. You just show the popular ones. And once you capture some history of that particular user, then you can shift it to this user-based collaborative filter. Scalability. Scalability would be always the problem with this recommender system, because every day more number of users may get added up to your database, and more items may also get added. So every time that could be a challenge to process and to add new data every time to the existing data. So that's about collaborative filtering, guys. So any questions on the collaborative filtering? Perfect. There's no question.
Sir,
Yeah, go ahead.
what if the user doesn't rate? Like every time the user does not rate, so can we take another metrics into consideration, or is it only
Yeah.
related to rating?
Yeah, as I mentioned, then you have to find out other ways through which you can capture some kind of a rating. So one more method I will tell you. So what if the ratings are not provided by most of the users? Then just consider it as 1010. If the person has viewed that particular movie, irrespective of the rating, consider that as one. If the person has viewed that particular movie, otherwise mark it as zero. This is a simple way. If
Okay.
people has watched, then consider that he might have liked that particular. So that is the one approach. If there is no rating, as I mentioned, you find some other ways through which you can populate these ratings. So as I given you the example, the time spent, right, on a particular page, or the time spent for viewing a particular video. So you just consider this YouTube one. Let's suppose in YouTube, video length is of 6 minutes, but that person has watched only for 1 minute or less than 1 minute, and he moved to another video. So what do you think? That person has liked that video or not liked? There's a high chance that he might have not liked it, right? Otherwise, he would have watched the entire video, right? So there you can go with that particular approach. So instead of going and seeing whether that particular video has been liked by that user or not, instead of that, you can go with this approach, like for how long he has viewed that particular video. And if it is like blogs or the documents, for how long that person has stayed on that particular page, could be one of the ways through which you can uh, calculate this pseudo ratings. We call it as a pseudo ratings. These are not actual ratings, but these ratings we have derived from other from other features of, or in some other way. Got it?
Yes.
Okay. All right, then. Okay, so this is your collaborative filtering. The same thing. Okay, I'm taking the same data. And see, sometimes it's not simple decision whether to consider the content based or whether to use collaborative filtering. Okay, and this in this collaborative filtering, whether you should go with user based or item based. In those scenarios, what we do is for one single use case, we go and build all these different models. We go and build content based, we build user based and item based, and then we'll go and test it, like which particular model is giving the better recommendations. So I told you how you can test it, right? You can just hide certain items of a particular user, okay, and just don't consider it while generating the recommendations. So if the person has viewed 10 items, just consider only 5 items and then pass it to the model and then compare with those rest 5 items to see that how many recommendations are matching with those 5 items. So you generate the recommendation from all these different methods and then you test it for all the users, like how many recommendations are getting matched. Okay, and then pick up the right method, for your final solution. So here in this collaborative filtering also, I'm doing all that pre-processing, what we have done in content based. It's the same code. Okay. Now comes the algorithm. Okay. So this is my same input, user input, which we have considered in the content based also. And now we will do all that calculation. Mhm. Yeah. So this is also the same code. Okay. So here what we are doing is here we are grouping the entire data with the user IDs. Okay, so to understand, the behavior of each of the user, like what all items he has watched. So here I've grouped it by the user ID, and here I'm just showing those one of the user ID. So user ID 1130. So 1130 has watched all these movies, and he has provided all these ratings. So here the grouping by the user is important because that's how we can find out the similarity between the users, right? So see, this is how the grouping is happening. So this is the user ID 75 and this is the group. This is the user ID 106 and this is his all history. Okay, this is another user ID and this is their history. So like that, I'm creating all the user groups and then I'm finding out the similarity. So here there are multiple different approaches or different techniques through which you can find out the similarity. One is like Euclidean distance, which we have discussed multiple times. The another is the correlation way. So correlation, if you remember, correlation analysis, we have used the correlation coefficient. The formula is this. Okay, if you can refer to the previous class. So this is the correlation formula. So you remember the correlation coefficient will range from between 0 and 1, right? If it, sorry, -1 to +1. So if the coefficient is towards -1, so they are like very much dissimilar, okay, because they are negatively correlated. If one person is liking a particular movie, if another person is not liking it, if that is the kind of a scenario, then the correlation would be -1, close to -1. If they are very much similar, if the person is liking, the other person is also liking and giving a high score, and this person is also giving a high score, then the coefficient would be towards positive, okay, towards +1. So that means those users are highly similar to each other. So here we can go with here it is using this correlation coefficient to find out the similarity. So here I'm creating a dictionary which will capture the similarity score between all the users, okay, with the active user or with the input user, the user which we have considered in the beginning, okay, as the input user. So this is my dictionary. So this is how it looks. So with this user ID 75, so if you see here, this is my user group 75. This particular user group, we have found the similarity with this particular input user, this guy. Okay, who has watched this 5 movies. Okay, so now this is the similarity. So it is looked out to be very high, 0.82. So that means towards positive, and it's high also. So it's a so we can consider this 75 user ID is very much closer to that particular active user. So if you see, there are some negative scores also. So that means where this guy is giving the highest score, the active user is giving the lower score. Wherever it is giving the lower score, the active user is giving the highest. So that's the reason the correlation is negative. Like that, I will find out the correlation between every user in the data. And wherever the correlation is high, so I can consider those users are very much similar to that particular active user. Okay, so what I've done is here I kind of processed this particular dictionary and converted that into a data frame. So this particular active user with this particular user ID 75, the similarity index is 0.82. With this particular user ID, the similarity is 0.58. So on and so forth. Okay, so this is my entire data. Then I'm finding out the top similar users. So I'm sorting this with descending order and taking the top 50 users, right? So, and based on those similar users, I will go and find out the recommendations. So these are the top. So with this particular user ID, the similarity, look at this. Okay, it is 0.9616, very much close to +1, right? So these are very much similar. Then followed with this particular user ID, then this user ID. So these are the top similar users with the active users. Now these are all the ratings which have movies and their ratings, which I've extracted from the original data. Okay, I merged this rating.df. And for this particular user ID, these are all the movies and these are all the ratings. Okay, and I also have the similarity index. So for other user IDs also, I will have the similar information. So always keep in mind here, I'm just printing the top 5. Okay, I'm just printing the head. This is the reason you are only seeing the 5 rows. Otherwise, the data is for all those 50 users. Now I'll go and calculate this weighted rating. Okay, so we have seen in the slide, this is the formula. We multiply the similarity index with the ratings to get the weighted rating. So this is my weighted rating. So this multiply by this. Okay, 3.5 into 0.96 will give me the weighted rating. Okay, and after that, if you remember, we have calculated the sum of similarity index and sum of the weighted rating. So these are those two columns, and after that we divided uh, this with this, this with this, to come up with the final recommendation score. Okay, so this is my recommendation score for all the movies which the active user hasn't watched. And then I will sort this score by descending order. So this is my movie IDs, and these are the highest score. So for all those movie IDs, the highest score is coming out to be 5, and all this could be recommended. I'm getting all the information for all these movie IDs. This is 2284. This is the 2284. The title is Bandit Queen, and this is the year. And these are the recommendation given to that particular active user. Now, if you compare, see, this is the same active user, okay, which we have considered in the content based. In the content based, if you see the recommendation, this would be a different list of movies, right? These are different list of movies. And here you will find different list of movies. So to improve your recommendation, what even you can do is you can also go with an hybrid approach. You generate the recommendation from both these algorithms and see which of the movies are common in the recommendation list coming out of each of these algorithms, from both these algorithms. And those common movies you can rank it high, and you can recommend it first and then followed with either of these models recommendations. Okay, so here I'm going with 10 recommendations. So these are the 10 recommendations which are coming out from my collaborative filtering algorithms. And if you go and further inspect this, all these movies could be different altogether in the nature. Okay, so their genres could be different. Okay, so the Bandit Queen, probably it would be high on drama, while War Photographer, it would be more of action movie or sci-fi. Okay, so you will find different varieties of movies. So in this case, there is a high chance that you can do that cross-selling, or you know s- recommending altogether different genres of movies to the user. While in content based, the recommendations, if you go and observe, those movies will be very much similar to in nature in terms of genres. Okay, the genres would be very much common, across all those movies. That's the difference between this collaborative filtering and the content based filtering. So here, if you see, there is not much training as such. Okay, we are not training the model. So here, it's all a mathematical methods which we are following, to come up with a rating. So these scores which we are generating at the end, in the end, these are nothing but the predictions. So these are the predictions what we are making out of this algorithm to see that which kind of movies the user may like it. Okay, and based on those uh, predictions of those recommendation score, I'm going and recommending the movies to the user. Hope you guys understood it. Anybody has any question anywhere? Is it clear? Harishri, Saurabh, Satish, Sharada.
Yes.
Okay, so just try once. Okay, go through the code. That would give you even better clarity. And let me know if you have any questions anywhere in the code or else in terms of understanding these particular algorithms. So we can discuss all that tomorrow. Okay, I will share the code. I will share the data so that you can try on it. All right, so that's all about for today. Tomorrow we will discuss another algorithm known as principal component analysis. So we'll understand, why we use PCA, and what is the how it works, and where all we can utilize that particular algorithm. Okay. All right, guys. Then thank you. Let's connect tomorrow. Have a nice day. Bye bye.
Thank you.
Thank you.